In this screencast, I'm going to explain the differences between categorical and numerical data. These are the two main data types that statisticians collect. Categorical data is data that can only take on discrete values or labels. This is typically synonymous with qualitative data or discrete variables. Examples, the number of people with blue eyes, brown eyes, green eyes, and so on. So you could do a survey. Those are categorical in nature. They're non-numerical. The blood types in a population, A, B, and O. A letter grade distribution in a class. So those are discrete letter grades, A, B, C, and A+, A-, and so on. States, countries, or continents. Those are discrete values or labels. The response on a survey. So maybe you have 1 through 5, and they can only respond 1, 2, 3, and so on, all the way up to 5. These can't be variables between, continuous, like 1.1 or 1.229. Univariate categorical data is typically presented as a histogram. So a histogram, we have bins here, 5 bins here, where the bins are confined to discrete values. On the x-axis, we have the different scores here. And on the y-axis, we have the frequency, or the number of respondents giving 1, 2, 3, 4, and 5. So now let's talk about numerical data. Numerical data represents observations or measurements that can be continuous, either continuous between negative infinity and positive infinity, or really small numbers up to really big numbers, or they can be confined to a certain range. Regardless, they're continuous in nature. And these are typically synonymous with continuous variables. Examples would be human height. Human height can vary on a continuum. The daily maximum temperature is a continuous or numerical variable. The speed of a car, so a speed of a car can take on a bunch of different values, right, on a continuum. The percentage grade in a class, while the letter grade is a categorical variable, the percentage is continuous or numerical in nature. To visualize univariate numerical data, we typically don't present in observation order. So here we have a bunch of students on the x-axis, and then we have their percentage in the class. So we've got a bunch of observations, but really the only thing we're measuring is the percentage in the class. So typically we wouldn't do this. We wouldn't put together something like this, where it's just a scatter plot of the students on the x-axis, the percentage in the class. By the way, looking at this plot, it makes it look like a lot of students are doing poorly in the class, but just keep an eye out for truncated y-axis scales. So if we really put this between 0 and 100, most of the students have a pretty good grade. So that's just something to look out for in general on plots. So instead of presenting it as an XY scatter plot, we would typically visualize univariate numerical data using a histogram, as I've mentioned in a previous screen class on the differences between univariate and bivariate data. So on the x-axis here of this histogram, we have the bin center. So we're taking all of the final percentage scores over here on the right, and we're sorting them into these bins. The bin width here is 2.5. And so, for example, this bin here with the bin center of 87.5, this really represents the total number of scores between 86.25 and 88.75. And I'll talk a little bit more about this when I talk about histograms. What you don't want to do if you have univariate data and you have bins on the x-axis and frequency on the y-axis is presented as this line plot with these dots connected. So it's more typical to present it as a histogram rather than a scatter plot or a line plot here. By the way, you can have mixed data types for bivariate data. I presented this burrito data in the previous screencast. And what we have here, we have categorical data on the x-axis. So these are particular discrete restaurants. But then on the y-axis, we have numerical or continuous data. So you can present mixed data types as I'm doing here. All right. Hope you enjoyed this screencast. Thanks for watching.